So our lesson for today is section 2.7, which is about solving inequalities with absolute values. So I'll go ahead and do like the beginning of class presentation where I'd like you guys to have your laptops closed, and then I'll let you guys know when we move to the part where you can work on your homework. So this lesson is kind of similar to what we did on Friday, because on Friday we solved equations with absolute values, and this one is where we're doing it with inequalities. So as a reminder, absolute value is the distance away from zero. So like the absolute value of -1 equals 1, because on a number line, -1 is 1 unit away from zero. So when we solve equations with absolute value, like the absolute value of x equals 5, you're going to have two solutions because there's two numbers that are 5 units away from zero. They're specifically x equals 5 and x equals -5. So with inequalities, though, you can have more solutions than just two. So for example, on this one, we have the absolute value of x is less than or equal to 3. What are some solutions to this inequality? Okay, yep, 3 would work. Maybe I'll put that on the number line. So here's the number 3. That would work because the absolute value of 3 is 3. That is less than or equal to. Yep, -3 would work. So I'll label these. Okay, so like you're saying, like any number in this direction.
Yeah, it's a variable, which means that if it's less than or equal to, which means it could go any number in that direction.
Okay, so if we chose some random number up here, let's say the number 12, if we plug the number 12 in, does that make it true? Nope, it would if this was going the other direction. So if it was x, or absolute value of x is greater than or equal to 3, that would work. Since it's less than, though, 12 wouldn't work. And I think pretty much any number up here wouldn't, right? Because like even if you did like 3.1, that wouldn't work as a solution. So are these two the only solutions, or are there other numbers as well that would be solutions? Yeah. Okay, so you're saying like any number in this section? Yep. So yeah, we could test that out by taking a couple numbers. So like 0, the absolute value of 0 is less than or equal to 3. You do absolute value of -2, the absolute value of -2 is less than 3. What about numbers in this range? Are there any solutions here that would work? No, because like if I took like, let's say -4, the absolute value of -4 would be 4, and 4 is not less than or equal to 3. And so even though -4 is less than or equal to 3, the absolute value of -4 is not. And so this would be like all of the solutions. And there's technically an infinite number of solutions in this range, because like you have 3 and 2 and 1 and 0 and -1 and -2 and 3, but you also have like 0.1, 0.12, 0.1, like you have all of the decimals in between there. So this represents an infinite number of solutions. So the way we would write this with interval notation is very similar to how we did interval notation for inequalities earlier. So we would look at this and we'd say, okay, well, what's the lower bound for my solution set in this case? Yeah. Perfect. Yep. So -3 would be my lower bound. And what would my upper bound be? 3. And so then I can say, okay, well, what about these bounds? Can I plug those numbers themselves in and get a solution? In this case, we can because of the or equal to sign. And so I'm going to put square brackets around that. And that would be interval notation for this solution set. If it had just been absolute value of x is less than 3 and it didn't have the option for them to be equal to, then you would do round brackets to show that you could do like -2.9 or 999, but you couldn't do -3 itself. So round brackets mean you can get really, really close to the number, but not the number itself. Square brackets mean the number itself is a solution.
Basically, you wrote 2 equations, you would get rid of those lines. And the absolute value, right? Which is absolute.
Mm-hmm.
Okay.
Yeah, so the way that I like to solve it is just to think about like what would make it true. But when we get to solving more complicated ones, like if it's 3x plus 12 or something like that inside the absolute values, then yeah, we will write two different inequalities to solve it. Yep. Any other questions on this? Okay, so let's do another one. This one is the absolute value of x is greater than 2. What would some solutions to this inequality be? Say it again.
I think it's the one I was trying to say in the first place.
Mm-hmm. Because you could do like 3, right? You could plug in a 4 or a 5, like. Uh-huh. Yep. So let's see, we'd have, sorry, I'm getting several answers at once. So like we could do any number that's bigger than 2, right? So I could do like 3, 4, 5, etc. I could also do really things like things that are really, really close to 2. Like I could plug in 2.01. That would make it true because the absolute value of 2.01 would be greater than 2. But the number 2 itself would not be a solution because it doesn't say that it could be equal to. So I would write that with an open circle at 2 because you can get really, really close to it, but not exactly that. And then you also said that it's any number less than -2. And that also would work because like even if you plugged in like -100, well, the absolute value of -100 is +100. And so +100 would be greater than 2. And this would be the entire solution to that inequality. Does that idea make sense? So on this one, since we have 2 parts of the number line that we're trying to describe with interval notation, we're going to have 2 intervals. So my first interval has a lower bound of -infinity and an upper bound of -2. You can't ever plug in -infinity into an equation because infinity is not a number. And in this case, plugging in a -2 creates a false statement because the absolute value of -2 is 2, which is not greater than 2 because they're equal. So I'm going to put round brackets around both of them. If it had been greater than or equal to, then I'd do a square bracket. Everybody good with that? And then I'll do something similar for this one, and I'll say this is from 2 to +infinity. And again, they both have round brackets. Now, both of these together are the solutions to this inequality. So the way that we say that both of these together are solutions is by putting a math symbol that stands for union, which means like it's both of these together. So that union symbol says that the whole thing, this and this, is a solution to the inequality they gave us. Let's do a quick check-in. On a scale of 1 to 5, how are you guys feeling about this stuff? Okay, awesome. So absolute value inequalities will always look something like this or something like this. Oops. Something like this, where you will either have like a range in between 2 numbers, or you'll have like everything below it and everything above, but the range between it are not solutions. And the difference between it is if you have the absolute value is greater than a number, then you've got to get everything bigger than that number, as well as like all of the negative versions of that, versus if you have the absolute value is less than a number, then it's everything smaller than that, but you don't want to go too far into the negatives, because like if you plug in a -5, like -5 is less than 3, but the absolute value of it isn't. So all inequalities with absolute values will look like one of those 2 forms, depending on whether it's less than or greater than. So when we're solving inequalities like this one, we need to know how we can figure out what x is, despite the fact that the stuff that's in the absolute value is more complicated than just a single x, like on the previous examples. So the way that I like to solve these is I say, okay, I'm just going to get the absolute value stuff by itself, which in this case it already is. But if there was like something being multiplied or added, you would, do the normal solving stuff to get rid of that. And then once you have the absolute value stuff by itself, I like to draw a number line and think about what does this stuff, like what could this stuff be? So for example, I know that it could equal 18. If this stuff equals 18, that would be a solution. It would also be a solution if it was negative 18, right? Because like absolute value of 18 is greater than or equal to 18, absolute value of negative 18 is as well. So I'm not necessarily looking for X right now. I'm looking for what the stuff inside the absolute values could be. And I'm going to use that to help me find X. So I say, okay, those two are solutions. And is this situation one where we're going to have like negative infinity and positive infinity? Or is it one of the ones where it's between the two numbers? Maybe show me with your hands. So this would be between, this would be infinities. Which one are you guys thinking? Okay, looks like you guys are thinking the infinities, and that's correct. Because like the absolute value of, let's say like 19, that would make this true. So 19 has to be a solution, and so would 20 and 100 and a billion, like any number in this direction, if you put it into the absolute value part, would make this true. And that's because it's a greater than symbol. And so I'm going to have these two sections of my number line that would give me solutions if this was just a single X in here. You know, like if this was the absolute value of X is greater than or equal to 18, that would be my solution. But I need to know what 3X minus 7 in those ranges would be. So since I have two parts to my number line, I'm going to write two different inequalities, which kind of goes back to what you were saying earlier. So one of my inequalities is going to be that 3X minus 7 has to be less than or equal to negative 18. That's corresponding to this part of the number line solution. And then on this part, I would say 3X minus 7 needs to be greater than or equal to positive 18, because I'm saying that this absolute value stuff needs to fit into one of these two sections on the number line. And then from there, so this is essentially what you do to get rid of the absolute value lines. So now that the absolute values are gone, it's just a normal inequality and you can solve it from there. So you'd like add 7 to both sides, which gives 3X is less than or equal to negative 11. Divide by 3, and you get X is less than or equal to negative 11 thirds. On this one, the process is the same, but you get a slightly different number because the 18 isn't negative. So what would that be? 25, I think. Divide by 3, and you get X is greater than or equal to 25 thirds. And you could graph this on a number line, and you could say, okay, well, negative 11 thirds is going to be like negative 3 point something. So it'd be like here about. And then 25 thirds is going to be 8 point something. So 1, 2, 3, 4. It's going to be like somewhere like right there. And X being less than negative 11 thirds is going to be this range. X being greater than it is going to be that range. So these are the solutions to the inequality because these are the numbers you could plug in for X. But this step is really helpful to be able to know what inequalities to set up to find X. Does that kind of make sense? And you could also write this as interval notation, and you could say it's everything from negative infinity to negative 11 thirds, round bracket around infinity, and a square bracket around 11 thirds or negative 11 thirds because it can be equal to. And then you would do union, square bracket. Go ahead. Perfect. Yep. So this would be interval notation, and this is what it would look like on the number line. Let me see if there's anything else. Oh, one thing just to keep in mind is if you ever divide by a negative, so we didn't do this in this case, but if this had been like a negative 3, then you would need to remember to switch the inequality. And that's one of the inequality rules. Yeah, so how are you guys feeling about that? Okay, awesome. All right, so let's do this one then. So on this one, what do you guys think our first step would be? Yep, we want a -8 because the absolute value step is not by itself on one side of the inequality. So we want to subtract 8 to get rid of that. And that tells us, maybe I won't do a line. That just tells us that 2x minus 4 over 3 is less than 7. So now that the absolute value stuff is by itself, now I'm going to draw a number line and think about where that absolute value stuff can be. So first of all, is it possible for it to equal 7? No, because but 7 will be our boundary point, and it will be able to get really, really close to 7, even though it can't equal 7 itself. Same thing with -7. So show me with your hands, is this going to be a between or a like infinity one, where it goes out to infinity, or is it going to be an in-between one? Yep, nice job. So our solution set is going to be in this range because we want the absolute value stuff to be less than 7. So like you could have 6 in here, or 5, or -6, but you couldn't have a number like 8 or -12 in here. And so this is going to be our range here. Now, in this case, we don't have to write 2 inequalities because this is only one section of our number line. But it's going to be what's called a compound inequality, which has 2 inequality symbols in it. So what that's going to look like is you're going to say 2x minus 4 over 3 has to be between 7 and -7. So I guess actually in some ways it is kind of 2 inequalities, because you have like this expression and a relationship between them. And you have like this expression and a relation. But I like to think of it as a compound inequality because it communicates that this stuff has to be in between these 2 numbers. Any questions about how I set that one up? Okay, so to compare it to this one, on this one, because we had 2 parts of the number line, we set up 2 inequalities. On this one, because it was a between solution set, we set it up as a compound one where it's still in between 2 numbers, but you can set it up as a single statement. So now to find out what x is, we just need to multiply by 3 to get rid of the fraction, add 4, and then divide by 2. So when I multiply by 3, I need to remember to multiply all the parts of my inequality by 3. So you know how we're always like, oh, multiply both sides by 3. In this case, you have 3 sides because you have 3 different expressions going on here. So when we do that, we get -21 is less than 2x minus 4 is less than 21. Because when we did 3 times this fraction, the denominator canceled out. And then my next step would be to add 4 to all 3 parts. And that's going to give me -17, I think, is less than 2x is less than 25. Divide both sides, or all sides, I guess, by 2. And you get that x is in between 25 halves and -17 halves. And in interval notation, our lower bound would be -17 halves. Our upper bound would be 25 halves, and then you'd have round brackets around it because these can't be equal. So let's do a check-in on this one as well. So scale of 1 to 5, how do you guys feel about this? Okay, and do you guys know like when to set it up like this versus when to set it up as like 2 separate ones and how to figure that out? That's kind of the value of setting up like a number line for this, like you're kind of like ignoring like the 2x minus 4 over 3 while you're setting this up. You're just saying this absolute value stuff is less than 7. You draw a number line for that, and that will help you set up this inequality for what that stuff inside the absolute value needs to be. Yeah.
So homework, when you do a number line for this, I put in the values of like when we solve it, or maybe the values of like.
Yeah, good question. So we're finding the solutions to this statement, which means the numbers you can plug in for x that will make this true. And so the solutions are going to be this, because this is what's saying what x can be. What this is saying is that this is what 2x minus 4/3 can be. But they're not asking for what that is. They're asking for what can you plug in for x. So you want to put this.
So we're not gonna ask what about.
So if you put it on a number line, your answer would look like -17/2. You'd have an open circle there. Then you'd have 25/2. I mean, probably they're not going to give you fractions, but your number line answer would end up looking like that. I think on your homework, when they ask you to do a number line, they'll give you nicer numbers than what I did, but yeah. Any other questions on this? Okay. So why don't you guys go ahead and try this one? There's nothing on your homework that is this hard. So if you can do this, then you'll be able to do anything on your homework. So go ahead and give this one a shot, and then we'll go through it together. All right, so on this one, what did you guys do first? Okay, perfect. Yep, because you want to get the absolute value stuff by itself. So because we have like absolute value stuff times -2 plus 9, we're going to undo the addition of 9, undo the multiplication of -2 to get the absolute value stuff by itself. So we get -2, absolute value of 3 times x minus 5 is greater than or equal to -90. And then what did you guys do next? Perfect, yep. So we'll divide by -2 on both sides, which gives us the absolute value of 3 times x minus 5 is great job on remembering to flip the sign. So your inequality should flip because you divided by a negative. And that gives you +45. And is this one where it's a inside thing or a infinity one? Yep, go ahead and show me with your feet, with your hands. So is this a like one where it's in between or one where it goes out to infinity? Yep, I think I'm seeing most of you guys got that. So This one would be a in-between one, so it could equal 45, so we'll have a solid dot at 45, because this stuff, if it equaled 45, that would make it true. Same thing with negative 45. And then any number in between there would also make it true, because like 0 is less than or equal to 45, 43 is less than or equal to 45, negative 43, if you do the absolute value, will be less than or equal to 45. So since it's a between one, I'm going to set it up as 3 times x minus 5 needs to be less than or equal to 45, and it needs to be greater than or equal to negative 45. Because if it was like negative 100, the absolute value of negative 100 would become positive 100, and that would make it false. So I have that. And since I have parentheses here, I'll go ahead and get rid of those parentheses by multiplying by 3. So I get 3x minus 15 less than or equal to 45, less than or equal to negative 45. Then I'll add 15 to both sides. I'm sorry, I'm writing so small. I think I might run out of room. So I'll get 30 is less than or equal to 3x is less than or equal to 60. Divide all sides by 3. And I get the solution x is less than or equal to 20 and greater than or equal to negative 10. And I didn't have to flip my signs here because I didn't divide by a negative. So it's fine if you divide by positives, but if you divide by a negative, then you need to switch the sign like I did right there. So if you got that it was like an infinity one and you were thinking that should be that, you probably forgot to switch the sign. Because if this had been a positive 2 instead of a negative 2, then you guys are right. It would have been one of those ones that go out to infinity. And then you would have got these same numbers, but instead of saying that x is between negative 10 and 20, you would have got that it's negative infinity up to negative 10 and then 20 up to positive infinity. And so remembering which direction your sign should go will make a big difference in the way your solutions will look. Oh, I guess I should write this in interval notation as well. So this would be square bracket, negative 10 and 20, square bracket. And again, it's a square bracket because it can equal those numbers. So if you did that successfully, or if you recognize where your mistake was, you should be all ready to go ahead and work on your homework. So you can open up your laptops and work on those. I'm going to answer any questions, and I also picked out a couple homework problems that kind of they weren't super hard, but just kind of like unique things I wanted to point out. So I'll go over those once you guys get everything opened up. Did you have a question? Like distribute this? You totally could have. So I did that at this step right here. So like I just kept my inside stuff the same, like all the way through, and then I did distribute it here. You could have done that way earlier and that would have been totally fine. Like right here or here. Yeah, any of these steps. So like you could have even done that as your first one. The only thing you can't do is distribute this inside because it's outside the absolute value. But yeah, you could have done it at any point. I just did it at this point. Yep. Yeah, you'd get the same answer because like essentially what I did was I just kept this the same. And then at this point I distributed it. But if I had distributed it up here, I would have got 3x minus 15, 3x minus 15, 3x minus 15, and then it would have directly gone to this step.
It would have been on either side, so you wouldn't have just plus 15 to the 25.
I mean, you do at this point, because like we did add 15 to all of those, but you wouldn't do it like the step from here to here is where we use the number line to essentially get rid of the absolute values. So this number line process of saying, well, what could I have in the absolute value that would be less than 45? That's that number line. Like from here to here, that process is getting rid of absolute values. So as long as you didn't try to add 15 before the absolute values were gone, then you would be just fine. Yeah. And I mean, technically, actually on this one, so I usually like to get rid of parentheses, but you could have also divided everything by 3, which would have given you negative 15 x minus 5 and positive 15. And then you could have added 5, and that would give you negative 10 and 20. But usually I find it more helpful to get rid of the parentheses before I solve. Yeah. I want to show, I'm just going to go through a couple questions that I thought kind of like stood out. None of them are terribly hard, but they just have like a couple nuances that might be helpful for you guys. So on question 2, I don't know if you guys have a negative number here as well, but it says graph the solution set of the absolute value of x is greater than or equal to negative 11. So this one's kind of an interesting one because literally you could plug in anything. Because the absolute value of any number, regardless of whether it's positive, negative, no matter how big or small it is, it's always going to be greater than a negative 11 because the absolute value always makes something positive, and a positive number will always be greater than it. And so in this case, your solution set would be the entire number line. Perfect, yes. That would be the interval notation for it. And you could also get one where you had no solution. Like if you had the absolute value of x is less than, say like negative 5 or something, there's no way that the absolute value of something could be less than negative 5 because a positive number can't be less than a negative number. And so if you had something like that, that would be no solutions. I didn't see any on my version of the homework that had no solutions, but it is possible that if you had an inequality like that, you might have no solutions. Yeah. Yeah, totally. So the reason why is, so the problem they gave me, not that one, that was one I made up, but the problem they gave me was the absolute value of x needs to be greater than or equal to negative 11. But it doesn't matter what x is. Like any number, if you take the absolute value of it, it will be positive, and a positive number will always be greater than negative 11. So that was one that I found to be kind of interesting. This one had a negative being multiplied in here. So we did one where you had to flip the signs when, like, before you solve the absolute value part, but this one has multiplication by a negative inside the absolute value. So as long as you remember to flip the sign, you'll be fine when you divide by that. But I want to show you kind of what the answer ends up looking like. So this is question 5 if you guys want to follow along, but you're always welcome to just work on your homework if you feel like you've got it. So on this one, since the absolute value stuff is already by itself, I would say, okay, I'm going to go ahead and do my number line thing. And this one is going to be one where it's inside or like a between problem, because this absolute value stuff could equal 6 because 6 is less than or equal to 6. Could also be negative 6 because the absolute value of negative 6 is less than or equal to 6. And it could be any number. Good grief, I don't know why that keeps popping up, but it could be any number in between those as well, because like 0 is less than or equal to 6. And so because it's a less than symbol, it's going to be everything in between. And so the way I would set up my inequality to get rid of the absolute values is I would say the stuff inside of the absolute values has to be in between 6 and negative 6. So that's my step that I do to get rid of the absolute values. And then I would subtract 3 from both sides. And that gives me negative 9 is less than negative 3x is less than 3. And then at this step, I would divide by negative 3. But because I'm dividing by a negative, I need to flip all of my signs, because this is a compound inequality where you're kind of like dealing with 2 inequalities combined together. And so that would give me positive 3 is greater than x, which is greater than negative 1. So that's because I divided by a negative. So all of the signs switch the other direction. So what that's saying is that x has to be in between 3 and negative 1. So on a number line, what that would look like is you would say, okay, well, X has to be bigger than -1, so it's all of these numbers, but it also has to be less than 3. And so it would be this range right here. But as you can see, like -1 is smaller than -3. So it might be more reasonable to write this as -1 is less than X is less than 3. It means the same thing because like X is still on the big side of the arrow compared to -1, and X is still on the small side of the arrow compared to 3. So these two statements are the exact same, but this one kind of makes a little more logical sense because usually we put the smaller numbers on the left side and the bigger ones on this side. And it is really important for when you do interval notation because the lower bound would be -1 and the upper bound would be +3. And in this case, you'd have round brackets. Because it wouldn't really make any sense to do interval notation as 3, -1, because 3 can't be a lower bound with an upper bound of -1 because this is a smaller number. So this would not be a correct way to write that. Does that make sense? So maybe I'll let you guys try your own version of question 5 before I go on to the other example I was going to go over. So you can try that out for yourself. Yeah. Just less than? Oh, I actually apparently missed that. Sorry. These should all have or equal to's. And this would actually be square brackets. So the way I solved it is how you would do it with less than. Yeah, sorry about that. Yeah. You have a question on a different problem?
No, it's
Okay, do you want to tell me what yours is and we can work through it? Less than 8. Okay, so the absolute value stuff is already by itself. So we're good with that. And then is this a like in between problem or a infinity problem? Yep. So if I were to draw a number line of it, I would say it can't equal 8 or -8, but it can be infinitely close to it. Like you could do 7.99 or whatever. So we'd set it up as -4x minus 5 is less than 8 and is greater than -8. So it's between those two. And then what would you say is your next step?
I added 5.
Perfect. And that should give -3 is less than -4x is less than 13.
And divide by -4.
Perfect. And that should give you +3/4 x and -13/4. Perfect. Yep. So how did you type your answer in?
I typed it up like not like the rounded bracket.
Uh-huh.
But it should-
Yep, because that's the lower bound. Because like if you were to draw a picture of this, x has to be in between -13/4 and 3/4. But 13/4 is the lower number. Even though like with the way you solved it, it ended up on the right-hand side, it's still the lower number. So just switch those on your interval notation. Yeah, of course. Any other questions on that one or other ones? Okay,
Um,
which number is it?
2.
2? Okay. Maybe I'll just make a blank slide. Okay, and what's the problem?
X. How absolute value of X is greater than or equal to negative X.
Okay. So what numbers on the number line would make that true? Okay. Are there any other ones?
Outward.
Yes, we could try it out and say like, does it make sense that like if I plugged in an 11, would that work? If I plugged in 1,000,000, and in this case it would, because 1,000,000 would be greater than -10. So all of those would be solutions. And also like -1,000,000 or -11 or, you know, those numbers. What about the ones in between though? If you plugged in a 0, would it make it true?
Yeah.
And like, what about any other number? Like, is there, maybe this would be a better question. Is there any number you could plug in that wouldn't make it true?
I mean, other than something less than -10.
So if it was less than -10, like say -20, that would still work though, because the absolute value of 20 would be +20.
I guess.
Mm-hmm. Yep, so the interval would be -infinity to infinity. And the reason for that is because the absolute value of anything will always be positive, and a positive will always be greater than or equal to a negative. Well, it will never equal, but always be greater than a negative. And so because it's a negative number that the absolute value is being compared to, it will either be all solutions or it could be no solutions if you had something like this. Because if you had something like that, there's no number that when you take the absolute value of it, it'd be smaller than a negative. Because positives can't be less than negatives. So this would be like no solution. And then this one is all solutions. And that's just because it's a negative. If it had been like a +10, then the solution you started with like the, 10 to positive infinity and -10 to negative infinity, that would have been correct if it had been x is greater than or equal to +10, because then like 9 wouldn't work. But since it's greater than or equal to -10, 9 or really any number will work. Good question. Yeah. Okay. What was your version of question 4?
Value of 2x plus 1 minus 2 outside of it.
Mm-hmm.
Less than or equal to 7.
Less than or equal to 7, so like that.
So like, added to both sides of 2x plus 1 plus an equal to 9.
Mm-hmm.
And did a whole, -9 is less than equal to 2x plus 1.
Mm-hmm.
That would be less than equal to 9, right?
Well, so is this so we know that 9 and -9 are the boundaries of this. Is this a between problem or a infinity one? Let's see. This one's actually a between one, because the absolute value of the 2x plus 1, if you do the absolute value of like say 1,000,000, 1,000,000 is not less than or equal to 9. So like sometimes I find it helpful to like think about a simpler version of this. So like essentially I'm like replacing this stuff with just a variable like y. Y could not be positive infinity numbers, because if you plugged in like 100 here, that would be false. And so the reason it's between is because this absolute value stuff is less than or equal to 9. And so it has to be like in, like an 8 or a 7 or a 6. Does that make sense? So it's like, if it's a less than symbol where you have the absolute value is less than a number, then that's going to be a between type of a problem. If it's one where it's greater than, then it will be an infinity type of a problem.
It's always in between, but it has to be.
Oh,
I
gotcha.
think that's my opinion.
Okay, gotcha. Yeah, because the way you would set this up is you would write it as 2x plus 1 is less than or equal to 9, is but also greater than or equal to -9. And you end up getting the same numbers for your boundary points, whether you solve it as like two separate like infinity ones, or if you solve it as a between problem. But your solution set that you'll write in interval notation or put on the number line will just, it'll either be like one interval or two intervals union. Yeah. 9. Yeah. Do you want me to do my version or your version? Yep. Greater than what? 8. Okay. Awesome. So what was your first step that you did? Okay, no worries. So we already have the absolute value stuff by itself, right? So on a number line, where can the absolute value stuff be? Could it equal, let's say 8, because that's going to be one of our boundaries. Like if so I'm like kind of thinking about all of this stuff. Like, could all of this stuff be an 8? And would it make it true? No. So, but that will be a boundary point. So I'm going to put an open circle to show that 8 won't work, but you could get really close to it. And then same thing with -8. If I had this stuff equal a -8, that wouldn't make it true. But is it between that has solutions, or is it on like the outsides? Yep. Because like you could have put a 9 in there. If that was 9, that would make it true, or a billion or anything like that. Same thing with the negatives. And so this means we're going to write 2 inequalities because I have 2 sections of my number line. So I'll say 4x minus or plus 4 can be less than -8, or 4x plus 4 can be greater than +8. So this inequality represents that part of the number line, saying that this stuff inside the inequality can either be less than -8, or for this part of the number line, it could be greater than 8. And then you go through and you subtract 4, which gives 4x or is less than -12, divide by 4, you get x is less than -3. Then you do the same calculations on this one, but you get 4x is greater than 4, you get x is greater than 1. So on your number line, you'd have an open circle at 1, and it would be all the numbers above that. And then you'd have an open circle at -3, and it'd be all the numbers below that. And then your intervals would be -infinity to -3, and they both have round brackets. And then you union 1 to +infinity. Because like this interval represents this solution. And then this interval represents this solution. Oh, and we have like one more minute, but I can go ahead and answer your question.
If it's in between, or if it's not in between.
So if the absolute value stuff, so like in this case, you had absolute value is bigger than the number. And so that means you have to include the numbers that are bigger than that number. And then also you have to include the ones that are like bigger negatives, you could say. And then the ones between would be if it was a less than sign, because these numbers have to be smaller than 8. But they also can't be so small that they're like -9 or something like that. So it's like if the absolute value stuff is bigger than the number, then it's an outside one. Yeah, and like the way I find it easiest to do is just to think about this stuff, what could it be? So just try out different numbers on the number line. So this number will always be the boundary. So you can set up your 2 boundaries, and then you can say, well, what does 0 work? well, if this stuff is 0, so at this point, you're not plugging in for X. You're plugging, like you're saying this whole thing. If this was 0, would it make it true? And it doesn't, so that tells me it's not an inner one. And then you could try the other ones. And they're what? Yeah, so they should automatically post because I posted a link to my Apple Drive. So yeah, it's just on our homepage. Yep. All right. I hope you guys have a good day. And if you have any other questions, let me know. I'll be updating your grades so far because like I told you guys how I do it once a week where like I copy the scores over from XYZ. So you guys should see your scores in Canvas showing up soon. Yeah.